Welcome everyone to September's edition of the Stuck in a Bucket webinars that KMC Controls is putting on to help try and teach you some tips and tricks. I am Fritz Wichern, joined again by Dave Bohlmann. We are continuing the series on networking, specifically looking at some Wireshark captures. Again, this is kind of a carryover. We went through some examples. Dave had some great stuff last month, but we didn't quite get through them all. So we wanted to do another session to get through the last, I think, 4 of them, right, Dave? And go through them. So again, we're giving away another patriotic KMC hat. They're pretty cool. I tried to steal one for myself, but it didn't work. So still hoping maybe I'll win it this month. I don't know. I don't think presenters are in the pool to win the hat, but you never know. So that's it. Let's talk a little bit about BACnet.
Okay, so we had posted some Wireshark recap files that we're going over as examples, and I think Fritz, there was 11 of them total, and last time we did 7, so we have 4 more yet to go. And the 4 that we're doing today are all MSTP, so that brings another dimension a little bit to it. So we'll go through that. And Fritz, you put in a new or the link for those files in the chat, right?
Yep, I'm gonna put a link to the zip file that has all the PCAP files in it. Okay. I'll put it in here right now.
Okay, cool. All right, so in the previous sessions we talked about what kinds of things are you looking for, what can cause those things. A lot of times the complaint is that the network's just too slow, meaning you're using Converge or you're using Connect or Total Control or Commander or some operating workstation, and the communication's just slow. It does not get the points quickly enough, and therefore maybe not all the points are coming in. And the way I handle all that is, first off, I do what I call step 0. So we mentioned last couple of times too. You just do sanity checks and make sure your cable is there, your controllers are powered on, and things like that. And then when you get to that point where it looks like the basic stuff is really there, then you can go ahead and do the Wireshark and that. And for when you open up Wireshark, there's filters, and we'll do that here in a minute. The first filter I mentioned here again is just BACnet. Now you only need to put that in there if it's a BACnet over IP. So when you do a Wireshark using our 5051 router, it will capture MSTP, and you do not need this filter. It's just everything in there is BACnet. So, and then again, just to reiterate these, there's different filters that you can put in to be able to help find things. And here's some examples, and we'll go over that. It'll make sense again as we talk about that here today for the examples. So these are just different kinds of filters. And, you're really, in many ways, you're trying to find a needle in a haystack, but you can blow away a lot of the haystack using these filters, and it makes it a lot easier to find things than that. So, and let's see here. This is just different examples again. All right, so I don't know if I said it enough times last time. If you really need help and all that, just send a cigar or 2, and then I'll be happy to help. So, or maybe Fritz or somebody. No. All right. So, example number 8, or Wireshark number 8. I put this in here because sometimes the Wireshark capture file, the PCAP file, is just too long, and Wireshark will complain. And so you can go in you go into the files and the preferences and the options, come in here to the let's see, layout section. I don't know why they called it layout. Oh, this is all just kind of one thing, but right here where it says maximum number of cached rows, which is the rows in Wireshark, it defaults to I think it's 50,000. And sometimes, especially when you're doing MSTP, it does not take long to have more than that because you have all the token cycle passing or token passing and all sorts of things in there. So you can just go in here and bump up how many frames or how many rows you have, and that way you can look at it. So this one again, like normal, the complaint is there's no slow networks. There's no messaging going back and forth. This one happens to be 12 minutes of capture on a 5051, which would be MSTP. And normally, when I do MSTP, I usually don't take more than 3 or 4 minutes. Sometimes people just forget and all that. So, and just kind of let it go. And we'll at the end here
you'll get more than you can. You get more info there than you can spend hours searching through.
Right. And we'll at the end of this we'll remind you all how to take an actual capture on the router. But so here is answer number 8. And so since it's MSTP, you don't see you have all these token passing messages. And again, for MSTP, a device on the trunk there cannot initiate a message, like initiate a request, unless it has the token. And so they take turns passing the token from one to the other, to the other, to the other. If you have the token and then you make a request, well, that device that you sent your request to, it can respond in the same manner without waiting for the token, but a lot of times they don't. So usually for MSTP, I do the filter. It's just MSTP dot, and it's this one here, MSTP dot frame underscore type is greater than 1. And then one of the other slides that explain a frame type of 0, that's the token passing. Frame type of 1 is pull for master, and that'll be most of the traffic. So we want to filter those out and see what we got here. So all that's left are things like requesting data and who is and IANs and responding and all that. So like normal then, I normally just click on the info label up here, and then it just sorts by that. And we notice that there's a lot of reply postponed messages, and I can keep on scrolling. They go on forever, never, almost. Some people get confused. Simply because you see a reply postponed does not mean that things are not working. All that means is when a device gets a request for information, it has to respond within 20 milliseconds. Or so. And a lot of times the answer or the reply that it has to send back will take a little bit of time to actually kind of build. And so whenever you see a reply postponed, that's not a bad thing. It's just the device saying, okay, I got your request, but I cannot send you the reply right now. And then most of the time, whenever that device gets the token in the token passing, then that's when it will send the reply. But the odd thing here, though, is there are so many of these reply postpones. So that means that there's a lot of requests going out, and might not necessarily be a great thing. And let's see if we can see what else we got in here. All right, so the complex ACK, those are the answers coming back. And you notice again on MSTP, there will be a source and destination. And since it's MSTP, these are only 8 bits or 1 byte. and they'll be in hexadecimal. You can use your calculator to convert if you've not memorized your hexadecimal table. But so this is actually Mac 18, and this is Mac 2. This is Mac, 39, and this is Mac 15 if you convert it into decimal. But the interesting thing is,
I gotta say that's impressive, Dave. I don't. I think I always just default to using the calculator.
Yeah, well, I force my students when my night job I teach, and when I teach digital, I force them to memorize some of this, and then I tell them, all right, and so when I tell them how much time I'm going to give them for a break, I give it to them in hex, and they cannot leave until they tell me what it is in decimal. But anyway, but the odd thing here, sort of odd, is you notice the source. The source changes a lot, but that's okay because that's an act, but it's the destination. So what that means, oops, I did it wrong. That means this is the answer going back to the destination, and the destination is either 27, which is Mac 39, or it's Mac 2. And those are the only two. So it's normally it's like 1. Here's another one that's going to 1B, so that's 27 in decimal. And so there's some off-panel reads and writes going on between the controllers on that trunk. Now, the other thing too is we can, now that I do not see Mac 0 for the destination. Normally Mac 0 is your router. So I suspect that Mac 2 is actually the router. And you can double check that. You can click on one of these things here. And when you go down here and look at the NPDU and expand that out, it says the destination here is this thing, which is AC110101. And then, and this again is in hexadecimal, but there's 6 bytes. There's not just 1. So that means it's going somewhere else off the trunk, and it's going to a device that's on network 100, like it says here. The BAC0, that gives you a big hint that this is actually a BACnet IP device. And BAC0 in hex is equal to 47808 in decimal, which should be recognizable. So we have a AC1111. I don't remember what AC is, probably a 172. So this is like 172.17.1.1. But anyway, so this is the hint that this is actually the operating workstation, whether it's connect or control or total control or commander or whatever. And Mac 2 is the router, the 5051 router. That's going to pass that message on. Okay. Now here, this one is the response is coming from 24 and going to 27. I'll just use the hexadecimal here. And the MPDU is blank, which means it's basically blank, which means the message is going from one controller on the MSTP trunk to another controller on the MSTP trunk. And that's fine too. But again, we want to know, why is there so many? Here's some more. This is, let's see, read property. This is the operating workstation trying to discover a device and that, which we don't care so much about right now. Then we come down here. These are the actual requests. And so once again, now the source is, here's the router. So the message is coming from the router going to this guy, and this is Mac 13. And again, on the MPDU, you can see that the source here, that's another big long hexadecimal thing, which is BACnet IP device. But it's going to Mac 13, whatever device has that. But still, there's an awful lot in here. So let's see here. What else can we see? So one thing is, all right, we've got a lot of requests for point values. So another thing then to check is how many whois's that we have. And there's not that many. So a lot of times, like we said before, one thing that slows down the network traffic is somebody keeps sending out a whole bunch of whois's, and you get a lot of IAMs coming back, and it kind of floods the network. But here that is not going on. There's just one global who is right here. And then here, this is interesting. This is the device with MAC 39, and it's looking for a device with an instance of 103, and apparently 103 is not responding, or else we would see it on here. So that's a missing device. It might be because it's on a different network. We don't know. But so we don't have to worry about who is this. That's fine. And when we scroll through all this, there's no nice big glaring errors or anything like that. So that's good. We don't have a noise on the line or anything. And since now we now we want to figure out, well, how many devices are on there. And so I changed my filter to MSTP frame type equal 0. I'm sorry, 2, because that, no, I'm sorry, 0, because that's the token passing. And then I go back up to the top and I just scroll down here looking for the lowest number. And there's my lowest number right there. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 18. So that means so I just went from, since it goes in sequential order in the numbering for the address, it's the source address, I counted 38 different things here before I got back down to 2. So that means there are 38 devices on this trunk. So one of the questions is, okay, do you have a repeater in there? Because you have to have a repeater if it's more than 32. And sometimes if they don't have a repeater, now this is kind of, it might be on the hairy edge, maybe not. Since we did not see any errors, well, then it's probably okay, even though they have 32. Okay, so now I want to know, all right, it sure looks like there's a lot of messages going on. So I get rid of my filter, and it looks like, let's see here. Oh, I go back to number here. So we start out at time 0 and time down here, it's 702 seconds. So in 702 seconds, I have all these messages going back and forth. And in fact, according to this, I have almost 90,000 messages, but most of them are token passing and all that. So we don't care about that. What we want to do is try to figure out how many requests or points are there happening. So you go back up, you filter out your token passing, and you pull for master. And now we got a whole bunch of messages, like we said. So one trick to find out how many messages is you go up to File, you say Export Specified Packets. And so here they have the total is 89,362, but the ones that I have left in from my filter is 13,430. Those are mostly requests for data and their answers. So I can come up here in my calculator. So I have 1,340, whoops, was it 13,430? Divide that by 701 seconds. So that means I've got 19 messages every second. And since each message will have one message will be a request and the other one will be a response, and most of them have a postponed. So it's almost like there's 3 messages for every point request. So if I divide that by 3, then that means there are more than 6 points being requested every second. And that's just a god awful lot. So now it's like, well, why are we doing that? So now you don't have to save it. This is just you just cancel that. So now I know that some of those messages are going to come from the operator workstation, and we know that MAC2 is the router. So you say ampersand MSTP dot source equal equal 2, one way of doing it. Or, let me back up, I'm sorry. We want to say parentheses, MSTP.source equal 2, or that's the 2 pipes, MSTP.destination equal 2. And actually, I could just leave it with the source because all I wanted to do is see how many messages are coming out from the operator workstation. So we'll leave it at equal 2. Okay. So sorry. So this means all the messages that are requesting points that are coming from MAC address 2, which is the router, those are the ones that are filtered now. And you can see there's just, again, god awful a lot. So this only has the request, not the responses. There's a few in here, reply, postpone, we won't worry about that because there's not that many. And we do the same thing, export specified packets. Here it says 3084. So now if I go to my calculator, I say 3084 divided by 701. So now we're down to a little over 4 point requests per second. So we know that the operating system is just hammering the network, or the operator workstation is just hammering the network with more than 4 point requests every second. And why is it doing that? I don't know. So that'd be one thing you could check. Pardon?
Just a few.
Yeah, just a few. And then what we could do is, okay, let's see who else is passing on messages. Oh, but one hint though, too, is why is it sending so many? If I click on info here, I've left that. So again, this is only the request coming from the operator station. And you notice it sure is, here it's actually writing to AV83. And so it's, in this one here, it's writing to AV83 on Mac, this would be 33. And it's writing the same point on Mac 18. And then on Mac, what is that, 16, 11, 27. So it keeps writing AV33 over and over to all of the controllers, or a lot of them. So now the question is, why is it doing that? And we could even pick on one. We could say, let's pick on a 14. Let's see how often it's writing just the 14. So we can come back in here and say, and MSTP destination equals. Now here you got to put it in decimal. So 14 in hex is 20 in decimal. Okay. Well, here's all the messages from the operating workstation to Mac 20, which is in hex 14. You can see all these 83s, and it's just writing to it. In fact, that's all it's doing. It's not even reading anything. And it's doing that like every, it's spread around. This is 40 seconds, and this one's only 23 seconds later. This one's only 14 later. What in the world is it doing? And that's where you got to go back to your whatever, converge or connect or whatever you're doing. It's probably total control of,
right.
or commander will not do this, so it might be a Jace or a total control doing that. So, okay. And then now the only other thing then is, all right, so we had more than 6 requests per second. 4 of them are from the operator workstation. What's the others? So now you can come back in here and say, all right, I want to make sure that my source is not equal to 2 and my destination is not equal to 2. Then when I filter that, so this is the messages going back and forth between the different controllers on the trunk. And again, we can skip out reply postponed. But you notice here, these are the acknowledgments. And a lot of them are going to Mac 27. A lot of them are not. So, but 27 shows up quite a bit, which would be Mac 39. So there's something in the program on Mac 39 that's causing a lot of this. And usually for MSTP controllers, if they're ours, somebody forgot to put a wait statement or interval statement in there. So, okay. But again, this is, there's not many, there's no errors in here and all that, so it looks clean. But there's just a lot of, the operative workstation is sending out an awful lot of messages. You got to fix that. And looks like there might be something going on with Mac 39 because it's also causing or sending a lot of messages. So, all right. And so this is just a summary then of what we found out. Seems like too many, a lot of pulling going on, many devices. Response times, we didn't check that, but sometimes it's too long, but usually, and sometimes they don't get a response, which is not that untypical or atypical for this many devices. But question is, are there wait statements? That's the big thing. Okay. This one, the complaint is we cannot write to a point. There's only 3 minutes on a BACnet 5051. And let's see here if I can, this one here. So here we are. And again, oh, it kept my kept my filter. Let me so here's my messages going back and forth, and I can hit the info, and a lot of these are going to, these are the responses. When you see the ACK or ACK, that's the response. There's a lot of them going back to 0. So 0 is probably our router, and when we do the MPDU, we notice the out, that's the router. This would be 192.168.1. I don't know, 2, probably 248, 250. I'm not sure off the top of my head. Anyway, there are some system status messages, which is kind of interesting. But what was the complaint here again? It was cannot write to a point. So let's focus on that. And so now we can filter on here and try to see if we can find the right. There's not that many messages. We can just kind of scroll through here and holler if you see the word right property. Postponed, say we get rid of that. So I did not see any rights in here. So, no. So either, since it's only a 3-minute window, either they did the capture when the write did not happen, or the write simply just is not being sent. There's no errors in here. We could check how many devices we have. And oh yeah, let's just do that. Device type equal 0. And we'll come back up here. Here's 0. So we got, oh, I got to sort by time now instead of info frames. So here's my 0. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 19. So that's not bad. It only has 19 devices. And okay, so that's not too bad, but the write did not happen. So and there's nothing glaring in what we did capture. There wasn't a whole bunch of messages in that. And so there are some system status messages, which you would kind of expect. Token cycle time is low, but where's the write? So we don't know what's going on because the capture did not try or did not see the attempt to write. So
during that time frame.
Right, during this time. So now this one is only 3 minutes. You could do a 5-minute one. And if it's a manual write, like you overwrite a point, well, just make sure that you start the capture first and then you do the manual write, and then it should catch it. So, okay. Number 10, total control cannot send a B&D file to an old 5901. So a B&D file is a configuration file that we use. And so whenever you are trying to configure a controller, it sends down a configuration file to the controller, and it says that for some reason that's not working. So let's go here, go to, let's see, whoops, number 10, right? All right, and let's get rid of, just for grants, let's get rid of our token passing and our pull for masters. Okay, so there's, I mean, it's really not that many messages. Okay, I mean, we could try to figure out, how many devices there are if we wanted to in that, but there's not that many messages. I don't see any glaring errors or any errors at all. So it's not like there's some noise or something on the trunk. So let's see if we can find the total controls trying to send the file. And if we go back over here, you can set MSTP to frame type 5. Let's see what happens when we do that. So instead of saying greater than 1, we'll just say equal 5. And that is, read property multiple. So only for read property multiple, or, I'm sorry, these are requests going out. So we've filtered out all the messages except for the requests. And right here, from here to here, total control is just reading different things. Whatever that happens to be, there's a list there. We don't have to worry about it. But here, atomic write file, that is total control sending out the message to the controller saying, I'm going to write you a file. Now, most of those BND files are rather large. The way MSTP works, each message can only be 480 bytes long, and the BND files are longer than that. So what BACnet allows you to do is to segment or fragment that long file into a series of shorter ones. And that's the segmentation here. So when you see message fragment, you see message fragment, I still can't say it right. That's not a bad thing. That's just, it's total control has divided up the message into chunks or into fragments. Okay. So let's go back here and do greater than 1 again, but we're going to look at frame 1579, and it should keep it there. All right, so here, 00, again, we look at the MPDU. That sure looks like a BACnet IP device, so that's probably total control, and 0 is the router. It's trying to talk to MAC 1, whatever that is, we don't know. And here it says atomic write file. And there's the first segment. But then the controller says, well, hold on, I'm not ready. And so, oh, now I got an ACK. Okay, so now that's a hint to total control. Okay, you can send the next one. And so now the next fragment. So now total control says the next one. Controller says, hold on. But now there's no ACK. And total control goes ahead and sends a message, the fragment after that. And another one, fragment after that, fragment after that. And it's not letting the controller send the ACK back. And then total control starts to say, hey, you're not acknowledging me correctly. I'm going to send it again. So it does that a couple of times. And somewhere in here, right here then, this is the controller telling total control, hey, we're all cattywampus. The fragments that you're sending me, I don't know what to do with them because you sent them out of order or you sent them without me acknowledging and all that. So this is another hint that there's something going wrong with the handshaking between total control and the controller to do what we call segmented messages. But the problem is, since this is a KMC product, the controller, it should handle it. It should do it right. So why is it not doing that? And so then you would, talk to me or talk to Fritz and then say, hey, I think there's a bug in the firmware because this is happening. Why is it happening? The messages look right and all that. And then if we go back to the description, it was an old 5901. So then that's a hint. Well, maybe what you need to do is update the firmware. And sure enough, as soon as they updated the firmware, everything was peachy keen. So how's that? All right. Last one. Then total control cannot read points or see many devices. Okay. And I go back up here. Whoops, not what I want. Sorry. Recent 11. All right. Now, just I'm not. You look here. There's interesting. I still have my filter on here, and when I do the info frames, it's like, oh my, what in the world is all that? These are the Wireshark color codes. When you see this, it's like something's wrong with the message. It's an incomplete message or something. It's malformed. There's something wrong with it. And it even tells you that there. If I scroll down, there's a bunch of them. So there's something wrong with the MSTP wiring or signal or something. There's noise on the line or whatever. But you should not see. You might see a few of these once in a while, but not nearly this many. And so what again was the complaint was cannot read points. Well, if your messages are not working because there's noise on the line, that's what you're going to see. So let's see. Oh, so now let's see. All right. Even though we have errors, let's see if we can check and see how many. Maybe it's not that there's noise on the line. Maybe it's something else. So I set my MSTP frame type back to 0, which is only the token passing. Scroll back up here. Let's find the lowest number. Down, down, down. Okay, there's a 0. Now let's count how many devices. There's 1, 2, 3, 4, 5. 20. 40. 50. There's 50 devices on this thing. Now, so if they don't have a repeater, that's not going to work. So you know that, first you find out, is there a repeater on there? But other causes for all those error messages would be maybe the end of line is set in more than the two ends, right? Or they shielded or they grounded the shield in more than one spot, or they just don't have a repeater in there or whatever. So there are several things to look at. So we have our problem here is too many devices on the trunk. So that's where I asked you, all right. Now, if you want me to tell you the answer, give me a cigar and I'll tell you what's wrong. But the other part here, we suspect maybe a broadcast storm. We didn't look into that yet, but that's what I would do. I always try to kind of divide and conquer. I know that there's too many devices on the trunk, so you got to, and even if they had a repeater, that's still a lot, and it'll slow down trying to get messages going back and forth. There was quite a bit of number of who is and I ams, and if we would look at that in detail, then that could give you a hint of whether or not there really is a broadcast storm. But the first thing I would do is tell them, look, you got too many devices. Check your end of lines. Check your shielding. Make sure that's all correct, and then you can go back and redo a capture and then see what your who is and I ams are. If we go back to here again, do the info. So now let's see if we can find how many who is and I ams we got. Man, there's a lot of errors. So we have here's who is, which is interesting. So here's a hint. What is going on? Because this is MAC 63, which is 90. That's 96 plus 3. This is MAC 99. Oh my gosh, in decimal. and it's trying to find this device over and over. But the odd thing is, it sends out the who is, and then, oh, let me see if I can. Yeah, okay. I was going to say it sends it out again pretty quickly, but But here's the thing too, though. The odd thing is here it sent one out to 16.16.1 and 16.16.3. And then here is the response from both of them. But then as we saw, it kept asking it. And so that's one hint is, all right, why is it asking? That's one hint in that there might be noise on the line. And so that controller could not see the response. That's why it keeps asking. So there's, but like I said, I try not to solve everything all at once. I find the problems that I can quickly identify and then fix those first and then check it again and then see what you've come up with. And you kind of go one problem at a time and you usually wind up getting done a lot faster. So, okay. Any questions or comments on that so far?
I haven't seen any come in, but if y'all have any, feel free to put them in the chat there.
Okay. And then finally, all those captures were taken by using our 5051 router. So here you can go into the router through its web page. You go into the device or diagnostics, and you can expand that. This is the device status. And so real quickly, it color codes the router's MAC blue, and then here's all the other devices that are out there. And then this one's kind of interesting because it says 23 is not there, 33 is not there. Looks like there's a little hole there. Maybe they're not actually there, or maybe they're offline for some reason. And this tells you here, so this counted 34. So, and then let's see, what did we count? 50. So at the time that this was taken, it only could see 34 of them. And then, like it says here, the bus is unstable. It's still analyzing that. What's going on? The token cycle time, it says, is 84, which is that's good. But here, I'm already suspicious. Why are these two missing? They're white instead of green. You can watch the token passing go by if you go to the token use. And then it's not animated, but you'll see the greens pop up, and then you'll see a light blue or yellow or red or whatever in these other places. And that will show you if the pull for master is being done. That's what the light blue down there means. So you can see if the pull for master from this last one goes all the way up here or not, just by this graphical representation. And since we're at 37, we should not, if you have your match master set properly on that last controller, you should not see the light blues coming all the way through here. It should only go maybe one or two past them, and that's all. So that's a quick and dirty way of doing that. Checking for that. We could have done that in the Wireshark too to see what the pull for masters are. Okay, and then metrics. Some of these, there's quite a bit of metrics. You basically, it counts how many transmit frames and how many receive frames there are. That's a lot. So the ones I have marked in yellow, it's okay to have a few there, but I don't get worried about them unless they are more than 1% of the total. Here, there's only 3. But you notice, though, we did have quite a bit of errors, and those errors, they don't really show up in here. So even the BACnet router kind of discards them in some way, some of the errors in that. Same thing down here. Now here we have a frame abort. So there's a hint there. Why is that so high? But still, it's less than 1%. It's okay. And then over here, oh, I'm sorry. This is not from the same capture as before. That's why we're not seeing many errors here. But if these guys here in particular, duplicate max or token retries or token timeouts, if you get any numbers there greater than like 2, then there's still something wrong, but it's not going to tell you what. So the way to do a capture is the next one. You'll see this screen.
Real quick, before you start on that capture, Dave, a couple questions that came in.
Oh, okay.
One asked if you can see the repeater through an MSTP capture.
No, the repeater is just, all it does is just conditions the signal so that it has no MAC address or anything like that. So the only thing that's going to show up there is, or the only thing that shows up in the capture are devices that actually have a MAC address.
Right. Perfect. And then another good question. Do we have any sort of, have you heard of a time frame for the single cable connection for the AE routers?
Oh, that's a good question. I don't know off the top of my head.
Yeah, I haven't heard any updates. I know, or I believe it's being worked on, but I haven't heard any dates as far as when that will be released. So
we'll have to ask Greg and see. Any others?
That's it. If you want to jump into taking a quick look at the capture, and then we can.
So I'm not going to do it live because, you know, when it's live, things go bonkers and all that stuff. But it's real simple. You know, just ask Bill Gates, or who was that? Zuckerberg. He did a live thing on Facebook and it went bonkers. Anyway, I digress. So on the MSTP capture, all you do is first thing you click the box here to start now, and then you have to hit save. And then it will start. And when it starts, it'll start, let's see here. It'll start down here. This is like a status bar, and it'll start telling you, you know, what percentage of its buffer that it can hold has been captured and that. So that'll keep going. You could tell it how much time you want to capture and it'll automatically start, or how many bytes you want. I normally don't, because I just kind of wing it and I just let it run for about 3 minutes or 4 minutes, and then I stop it myself. And then the way to stop it, if you do not set match time or match length, then all you do is, so you see here, I've captured that. My buffer is 20% full. So then I just check the stop now, then I hit save, and then it'll sit and think a little bit. And then this button down here, the download capture, will turn green, and then you press that button and then you download it to your PC. Now you have your capture. So pretty easy peasy, but people tend to forget about hitting save. So whenever you mess on this page, you got to hit save. So, all righty. That's all I got today.
I love it. Well, looks like I didn't catch the dates there, but keep an eye out for the invite. Our next webinar will be on October 17th in October. So keep an eye out for the invite on that. I want to thank everyone for joining and the questions there. And again, if you have any ideas or thoughts for stuff you want covered in a Stuck in a Bucket webinar, feel free to email me, email Dave, email your local sales engineer with ideas. And I think that, Dave, thanks for coming on and sharing all your wealth of information, at least some of it.
Well, thank you. It's been really fun.
I'm gonna have to start memorizing my hex addressing. So
yes. Or else, you know, you'll fail my class at night, or else you won't have your breaks. So, right.
Yeah, don't get the break. Yeah. Right. All right. Well, thanks everyone. Y'all have a great day and a great weekend.
Right. Thank you.
Bye-bye.